So I've come up with an idea. So if the Conservatives get back in, and Rishi Sunak gets his wish for national service, we could put all those young people in the fields at night to pick up the harpoo. That's that bit soft. So that was my idea. The other one is Fred and I were thinking about if we could come up with an algorithm and a little lawnmower pooey picky up thing that would identify horse poo, we could go to Dragon's Den. As our company, poos are us. Meanwhile, we'll talk about diagnostics, which is really what I do. So obviously, I've set the scene now in terms of worm control, understanding the worms that might be there in the population, reducing the risk through environmental measures. So to answer one of the questions, certainly for Strongyles or small red worm, the development time for eggs through to infective L3 is absolute minimum of around a week, at optimal temperatures of about 20 degrees and high humidity. So, and we did some work, and there's been other work done abroad, but in the UK, in Glasgow, we would start to pick up L3 within the second week after deposition of infected poo onto clean grass. And then that really scales up very quickly 2 to 3 weeks later. So we said lift dung at least once a week would be the minimum. From a practical point of view, I think when people do it, they actually find if they do it a bit more frequently than that, it's a bit easier rather than it's like leaving your dusting for a whole month. It's better to maybe dust once a week, and then it doesn't seem such a big chore. So, but from a scientific perspective, once a week. The Oribitid mites, the development of the cysticercoid larva of the tapeworm takes several weeks. So what you want to do there is lift that poo regularly to get rid of tapeworm eggs, for example. And you don't want the mites to eat the tapeworm eggs within the poo, and the mites are going in and they ingest it serendipitously. Or maybe they like them, I don't know. I've never asked an Oribitid mite whether or not a tapeworm egg tastes good. Obviously, you want to reduce the opportunity for that, so if you do daily removal, that would reduce the opportunity. So I think daily would be ideal. So in terms of diagnostic tests, we've got a raft of tests available now, and this is a sort of outlook, and this is where things have changed since I started talking about worm control. I think the first time I spoke here was maybe 2010. So we have coprological tests, and there's been a fantastic uptake of egg count testing in the UK. I think hats off to the sector. We've a long way to go, but the recent Project Worms survey that was done by some of the big corporates, together with, I think, BIVA, they questionnaire about 4,000 people, and about 50% uptake of fecal egg count testing is what the respondents said. Obviously, they were a bit biased because people that complete questionnaires have obviously got an interest. But that's amazing, because when I started in this game many years ago, people really weren't doing that, and they looked at you as if you're a bit mad, you know. That's great, and I know many of the big stud farms around here are converted. When we started to do some of our studies with them with HBLB funded work, they realised the value of doing egg counts, particularly in mares, and they were reducing anthelmintic treatments to mares by about 90% within a year. On top of that now, what we want to do is build on that and get people to do the egg counts, but also to do an efficacy test once a year, so do a check, a drench check. Ideally, in the UK, probably you're best to do it in the summer when we know from the natural epidemiology of Strongyles, this would be for, but Parascus as well, the egg counts are likely to be higher in the summer, so you've got a better chance of having enough horse that come into the category to test of over 200 eggs per gram, and then the numbers are a lot better than just doing a reduction test in 2 horses. Perhaps you could do it in 12. We've now got antibody-based tests available, which I'll tell you a bit about, blood-based tests for tapeworm and small red worm or cyathostomas, and a saliva-based test for tapeworm. And obviously I have conflict of interest because I now work for the company that markets these tests, so just like to flag that up. And then other tests that are available or could be available in the future or for other species of worm. Fecal egg count tests are great. They really tell you a lot about what is being shed onto the pasture. Fecal egg count tests, if there's one take-home message today, they don't really tell you anything about the burden of worms within an individual animal. They do not correlate with the adult worm burdens because they don't account for male worms, for example. They don't account for the differential release of eggs from individual female worms, and they bear no relation to the larval burden, because larvae within a horse do not produce eggs. And some horses, particularly with small strong jaws, could have a burden of 80–90% of larvae, particularly in the autumn and winter. What egg counts are useful for are telling you what is going out the horse and onto the paddock, and therefore you're going to target the treatment of those horses to reduce contamination. The good news is that what we know from lots of studies, and it's the same in humans, it's the same in sheep and cattle, is that worms exhibit this, particularly in adult horses, this negative binomial distribution. So if we were a group of people that were infected with worms, what we'd find, because we're all adult and healthy, 80% of us would have a low worm burden, and there'd just be these people here. This 20% here would be our people with the higher burdens, and if we were grazing paddocks with them, they'd be the high shedders. And that's what we do by applying diagnostic testing and fecal egg count testing, is we say, well, we need to apply an anthelmintic treatment because we want to reduce egg contamination onto pasture, but we need to work out who is shedding eggs and who do we not need to treat. And if we actually do it such that we don't treat some horses that have got low egg shedding, what we do is the eggs that they put out, because they've not been treated and they haven't had the selection pressure of an anthelmintic, the eggs that they put out, if the dung isn't removed completely or not at all, those eggs will develop to larvae, they won't be through a selection pressure, and they'll dilute the resistant alleles and genes of the worms that have survived in the horses that have treated, or the eggs that they put out. So that's how it works. And we've done lots of studies on this. It's just one that we did that was funded by the Elise Pilkington Trust, where we looked at, these were leisure horses, and we looked at them over a whole season, and we looked at their egg shedding category. And the take-home message is most of these horses, the vast majority of these horses, I think it was 400 or so, they had egg counts under 200 EPG. And there was a small proportion of horses that had a higher egg shedding level. And what we found over the course of the season, there was consistency within the group of egg shedding level, and horses really only changed if they were treated, or younger horses changed category more often, and we didn't really see any difference in egg shedding by following that strategy. This is a bit closer to home. This is work that was funded, a big study that we did with the HBLB's funding, and I mentioned the questionnaire that we did. And actually this data is probably from horses from stud farms of many of the people here. And what we did is we took about 1,200 samples from horses from thoroughbred stud farms, and we did egg counts. Now, at this stage, this was way back in 2012, probably we did this, or 11. All these stud farms were on interval treatment programs, as we ascertained from questionnaire. So they had very low levels of parasitic eggs being excreted, because horses were getting ivermectin every 6 to 8 weeks, sometimes more frequently. And what we found was that if you look at this graph, this is the number of eggs per gram, and this is the percentage of horses that had that eggs per gram. And we used this method down to a 1 egg per gram detection limit. And what we found was a vast majority of the horses were in this very low egg shedding category. And only 11% of the horses that we tested, of these 1,200 individuals, 11% excreted 80% of the eggs that we counted. And actually, nearly 70% of those 11% were actually just youngsters. And you can just see this is just another way that we've graphed up the data. So if you look at each of these groups of different animals in different age categories, we find that if we look at the 200 eggs per gram threshold here, even within these younger animals, the young females and the yearlings, foals, we find many horses are actually under 200 EPG, and then very few animals, this is the frequency of individual tests above a 200 eggs per gram threshold, are very low. Particularly, these are the mares and the odd stallion. There's hardly any of them were above 200 eggs per gram. So we went back with that data to the stud farms. You're using all this anthelmintic and it's costly, and you could do an egg count test, which would be the same price or cheaper. And not only would you reduce your effect on resistance and you'd reduce your effect on the environment, you could potentially save money. And we've published data as well to show that you can save money by doing egg counts. And some of these stud farms actually employed their own staff or new staff to actually run their egg counts. It was really impressive how they engaged with our outcomes of our study. On the stud farms, we found there was 100% prevalence of strongyles, not to be unexpected, with about 50% of these horses infected, but most of them had low egg counts. And we found parascaris eggs on 50% of the farms, and that was a bit worrying for us because we knew a lot of these foals were getting a lot of ivermectin at the time, so we thought this is probably an indication of resistance. But not that many of the foals had, at individual level, had egg counts, but they were there. Even in that snapshot, we were a bit worried because of the levels of ivermectin. And again, we found a prevalence of tapeworm, about 40% of eggs. Again, egg counts are not sensitive for tapeworm infections. I'll come back to that. And less than 10% of them were detecting excreting eggs at the individual level. And this just gives you an indication of what I said, though, just a little cartoon to show that in a group of horses, if there's a particular group in a field, if you went and egg counted them, the majority would have a low egg count, under 200 EPG, for example, and we have this small proportion of animals, and it's usually the same horses time and time again that come up with a higher egg count. And what you do is you treat these individuals to reduce your contamination levels, to break the life cycle, and you don't treat these individuals, and if any of them are excreting eggs, you create a refugia of worms that are under selection pressure. So at the next round of infection, the more susceptible worms from these horses will mate with the more resistant worms that have survived treatment in these horses, and hopefully would have a dilutionary effect. I have to say none of this has been proven quantitatively in horse worms because it would be so difficult to do because of the different species, but there are some indications from work in sheep about the impact on resistance alleles by creating a refugia. Sorry to go with so much science just before lunch, guys, but anyway, I'll try and keep it more practical. So this is just little bubbles to give you some guidelines about egg counts, use them to direct treatments to reduce contamination with eggs into the environment. You can test individual animals from 6 months. I'll come back to Parascaris in a minute. And then you would assess your egg counts every 8 to 12 weeks in the grazing season, depending on perhaps what your egg counts were like at the time of treatment. If there were many high ones and you were looking at youngsters and you didn't use a macrocyclic lactone, you might want to shorten the period between how frequently you do your fecal egg counts. It's worth keeping in mind that obviously the persistent products, particularly moxidectin, should suppress eggs for a bit longer, so you probably want to have a minimum of about maybe 12 weeks. And if your egg counts are really high in lots of animals at 12 weeks, then you probably want to reduce the time between doing one egg count and the next. So you'd be working with your egg count provider, your vet, just to look at your patterns and design it around your individual observations for that farm. It's worth keeping in mind at the moment, because we've still got relatively high use of macrocyclic lactones, that over 99% of the strongyle eggs that will count will be small red worm and not large red worm. However, if you're working or you're on a stud farm where you haven't used macrocyclic lactones for many years, you might want to consider working with your vet and using a parasitology lab to maybe take a bulk sample and to culture those eggs and look at the third stage larvae, and that will enable the identification of small red worm or small strongyles from large strongyles, Strongylis vulgaris, because obviously that's a very pathogenic worm and you need to have an alert about whether it's there or not. In foals over 6 months, you can use egg counts to identify the eggs that are present. So have the foals got parascarid eggs? Have they got strongyle eggs? Because that will determine your treatment, because you'll remember from my earlier talk that ascarids have much more resistance to macrocyclic lactones, such as ivermectin. So if there was a lot of ascarid eggs in the counts, you would be looking to treat with fenbendazole or pyrantel. And if you had strongyle eggs, well, you know that there's a lot of resistance to benzimidazoles and perhaps pyrantel, so you might consider applying a treatment of macrocyclic lactones. But of course, in your programme, you would be doing an efficacy test as well, just to check that the products that you're using are continuing to work. It's great, everyone's doing egg counts, but we want you to do them properly. We don't want you just to take a random sample and then submit it to the lab. And we found that actually, when we were introducing this and pushing egg counts, that a lot of people were taking samples and the processing of them wasn't very valuable. So we've done a lot of work in the background to look at the variability within egg counts and to train people. The first thing that we did is Hannah Lester, who was a PhD student with me, she took hundreds of samples from individual horses, and she looked at the level of egg dispersion within the dung pile. And what she quickly realised that as a horse poops on a bit of stable or pasture, each dung ball within that pile will have a different egg count. So if you took that sample and you used a method, say a multiplication factor of 50, if you just counted that horse would have a 200 eggs per gram egg count. But if you just took that dung ball, it would only have a 0 egg per gram egg count. And that would make a big difference to if you would treat it or not. So it's really important to make sure that your sample is representative. So we recommend you always work with freshly voided faeces, because obviously eggs hatch and the larvae come out in a couple of days, so that would be a false negative result. And then you would collect at least 3 of these balls and give them a really good mix and collect at least 5 grams. and then put it into a bag and squeeze out all the air, because air helps the eggs hatch. You don't want any air in there with the oxygen. Or if you're putting in a box, fill it up to the top. And mix, mix, mix. You can't do enough mixing, I would say, to reduce the variation that we see. And we did a lot of data, a lot of publications around the variation that you would see at egg count, at dung level and ball level and at various other levels. And then keep it cool, because obviously the eggs hatch if it's warmer, and process within 5 days. That was some work that Martin Nielsen had done in the States. And that will make sure you get the best value that you can out of your egg count analysis. And then we built on that. We looked at trying to create some simple and straightforward guidelines to encourage people to do efficacy testing. And basically, it's just the same process again. You would collect samples in the same way. You would do an egg count and treat the horses either over 200 eggs per gram, I would recommend probably for stud farms, and then you would go back and collect the samples from the treated horses in exactly the same way again, trying to reduce variation as much as possible by mixing, processing the sample properly and in a timely manner, and then you would calculate the level of efficacy at 2 weeks post-treatment in terms of percentage reduction in mean egg count, as I mentioned earlier. The limitations are that fecal egg counts don't correlate with small red worm or ascarid adult or larval worm counts, so we have got a bit of a gap in our toolbox there, and we've tried to address that by developing a blood test for small red worm. They have poor sensitivity for detecting tapeworm infections, and that is because what happens is the tapeworms are hermaphrodite, I didn't mention that earlier, and they produce these segments from their tail end, and in these segments are the male and female organs, and then they fertilise, and you have these segments become packed full of eggs, and then the tapeworm sheds these eggs and these segments intermittently. So if you hit a horse that's got a lowish tapeworm burden that's not got any proglottids or segments being shed, it will be a false negative. Or on the flip side of that, if there's lots of segments being shed and there's not proper mixing, you could have an overcount estimation of eggs. So we wouldn't recommend egg counts for detecting tapeworm infection. The other thing is that several studies, not done by ourselves, but other groups in the European Union, when they've gone to abattoirs and they've counted tapeworm burdens and they've looked at the population of tapeworms in horses, they found actually that many horses comprise a high proportion of immature or sterile adult worms, and you would not detect them by a fecal egg count method. So antibody tests can be used instead to provide information on levels of worm burden, and these can also, like fecal egg counts, be used to detect treatments by following the specific guidelines for each test. And this is a little cartoon to explain how the antibody tests work. So as you can imagine, if it's a small red worm or a tapeworm, the worms are in the intestine, and they're these great big, they're quite big antigenic multicellular parasites, and that's probably why they survive in the intestine. They're kind of protected in a way from the immune response. But they do generate an immune response which can be protective or not, and then we can measure these antibodies either in blood, we can measure it in milk, which we've done, and you can measure them in saliva. And then what we know is that antibodies to certain worm components, certain worm molecules, can be detected in blood and saliva. And for certain antigen-specific antibodies, we've shown that the levels of these antibodies can correlate with the level of burden within an individual horse. And then if we were able to measure these, and it's the ELISA, the enzyme-linked immunosorbent assay method, allows us to quantify and measure these worm-specific antibodies, we can then get a readout which can tell us what the level of antibody is to these antigens within a horse. And then from the data that we've analysed, we can give an idea of the level of burden within that individual based on the worm molecule-specific antibody level that we measure. So in the UK and in the EU, we're very lucky because we've now got saliva and blood tests to measure tapeworm infection. We've got the small red worm blood test to measure levels of cyathostomas, and we've also available through Liverpool University a blood test that will tell you about exposure to fluke if you are grazing horses with ruminants and you were a bit worried about contamination or perhaps clinical signs of liver fluke. So there's a blood test available for liver fluke as well. The tapeworm blood test is available. It was developed actually at Liverpool just before I went there, and we initially marketed it through Diagnostics, which was a company that Chris Proudman and I set up about 20 years ago. Diagnostic no longer exists, so Austin Davis has taken on the blood test, and they've developed it and optimised it and validated it. And that will measure antibodies in the blood to little excretory molecules that the parasite secretes in the host. And what we know is that the level of antibodies to these products correlates with the level of tapeworm infection. And because we measure these in every test against a calibration curve which measures total antibody, that allows us an internal quality control measure for every test. And that means we don't report an antibody level, we report a serum score. And these serum scores are then categorised as low, borderline or moderate high, with treatment recommended for horses that fall within borderline or moderate high results categories. And we recommend, because antibodies in blood take a little time to decrease after treatment, so you treat the horse and then the antibodies take a while to decrease, you don't use the test within 4 months of treatment. The Equisal's tapeworm saliva test works on the same principles, except it measures antibodies that are produced in the saliva, so you don't need a vet to come out and take a blood sample. And it's achieved great uptake in the UK, and we also have samples submitted from EU. We've tested commercially over about 210,000 samples from horses over the last 8 years or so. It's a bit more complicated because horses, obviously, saliva is a lot more variable than blood, because blood is blood, basically, whereas saliva increases and decreases, because I'm sure you'll all go through there and get your lunch, which I think you're probably hoping you can have quite soon, so I'll keep this brief. And the horses will increase their saliva when they've eaten or they're near food or whatever. So we have to account for that dilutionary effect within the saliva, both by the guidelines that we provide, and also by applying a three ELISA test format, which measures the total antibody within the saliva, which we measure the antigen or the parasite or worm-specific antibody against. And we also take account of the stickiness of saliva as well. We run a third ELISA to account for sort of the binding to the plate. And Kirsty, that works with me, and Corin, and others at Austin Davis validated this several years ago, and they showed strong positive correlations between the level of antibody to the worm proteins, or the worm molecules, and the level of infection within individuals. So the test identifies one tapeworm infection with high sensitivity and specificity. But importantly, from a clinical viewpoint, at the 1 plus tapeworm burden, no horses with a pathogenic burden of over 20 tapeworms is misdiagnosed. So it's a good test to identify horses that have those potentially more damaging higher worm burdens of tapeworm. This little cartoon just shows you work from Corin at Austin Davis. This is her horse, and she looked at the levels of antibody concentration when she fed the horse hay, and then she followed the horse over time after feeding the hay. And you can see that the dilutionary effect, because the horse is salivating, because it's eating, is the level of antibody is too low to be detected. So it's really important, if you're using the test or advising people to use the test, always don't feed the horse for half an hour before using the test, because it will come to us and we won't be able to detect the antibody, and we'll get back to you and say you had to do another test. We usually provide it for free, though. We're nice that way. But it takes more time, and then you don't have the result quicker. It doesn't, like the serum test, it doesn't provide an exact value for the number of worms, but it provides a saliva score. Again, the 3 ELISA format provides a value, and then that's measured against a calibration curve, so you get a score categorised as low, borderline or moderate high. And then treatment, again, is recommended for horses that fall within the latter 2 categories. In terms of when to test, so I've spent a bit of time looking at the epidemiology of infection and understanding a bit about the intermediate hosts that live on the paddocks that transmit the parasite from horse to horse. And what we would recommend is that you test horses in spring, and in that way you'll identify infected horses that are more likely to contaminate paddocks with eggs during the optimal transmission season of the mite, which is the late spring and summer. So you can get in and you can get those horses treated that are going to contaminate the pasture over the summer grazing period. Other studies have shown that horses tend to accumulate burdens over the summer, and they have these higher burdens in the autumn, which might be pathogenic and cause disease. So another good time then to test is again in the autumn to identify those horses that have accumulated a significant burden of worms, and they attach with these suckers here, and they cause the damage. So what you want to do is identify the horses that have got a burden in the autumn so you can treat them appropriately. And again, if the horses are outside, that will reduce contamination onto pasture, but it will also reduce the risk of disease because they'll have lower tapeworm burdens. Salivary antibodies decrease quicker than they do in serum, so you can test a horse a minimum of 3 months after the last treatment. And that's just indicated in this slide, where we took horses that weren't exposed to new infections, either because they were grazed or they were stabled or they were grazing very clean pastures. And what we found is all horses that tested initially was positive fell within the negative category within 12 weeks of treatment. So we recommend a minimum of 3 months after treatment if you would want to test again in the saliva test. And what we found is, if we look at, I just analysed the data last week from our commercial data set, and this is over 204,000 individual equisal tests. These horses were tested, and we find that only 1 in 3 horses test positive. So that's a considerable reduction in anthelmintic use compared to an all-treatment approach, because you're only going to treat 1 in 3 horses overall if you use the test as 2/3 are negative. This is just an exemplar prevalence across individual yards. And as I mentioned earlier, tapeworm's a bit funny. You see a great range in prevalence, and this has been published a lot by various people over the years. This is just some of our data. And you can see that most yards here in this 46 yards that we looked at, many of them, the prevalence of infection falls below 10%. And there's only a couple of yards where more horses are infected over 50%. And these would be what I would call problem yards. And we sometimes work with these. We like to support our vet customers and clients and their clients in trying to solve the issues with these problem yards. Why are so many horses infected with tapeworm? Is it just bad pasture management, which we can solve, or is it resistance, which is a big worry? And this would just be a problem yard that we've got as a Scottish yard, where they used to just test in January every year. And what would happen would be they would test all these horses that were positive, and they couldn't really get on top of what was going on. And really what we're doing is we've just done this survey. We test the horses every month, and what we find is if you only test annually, you're going to miss all this contamination from positive horses throughout the season. Particularly this one individual here, he's such a high shedder, he'll be spitting out lots of eggs between 1 January and the next, and you never really get on top of the infection. They also do dung removal, but these are the people that move the dung removal to the field at the top, so we've advised them about that to try and change that practice as well. So we've been working with our vet and with the client to try and get them to get these saliva scores down. This is very recent data that's come from France, where a vet had contacted us about some dead horses or horses with colic that she'd opened up, and they were full of tapeworms, and they'd had a lot of praziquantel. And this is just the very first data. No one's seen this before. She sent us samples in February from some of the horses before they were treated. And the only thing to take home from this, every horse that starred on this bar chart had an antibody result which was off our scale, so that we found even this small group, over 50% of the results were off scale. We couldn't measure the antibodies, we'd dilute it out if we can get a better measure. And if you look at our overall database of over 200,000 tests that we've got, usually we only get 1.3% of horses off the scale. So there's a serious tapeworm resistance problem on this stud. These all had high burdens. They've gone in with Pyrantel, and we're looking at their April and May scores, and we're going on. And what we're seeing is not so many are off the scale now. So it looked like that drug might have worked and might have killed the worms a bit, but we're going to have to follow through. The stud farm doesn't remove dung from the paddocks, and we said that's one of the main things that they could do, and also to stop using praziquantel. So the vet's gone back to the client wasn't very keen on the dung removal, but Paul helped me out, and he sent me some nice pictures of dung removal things, and because the guy's quite techie, so we're hoping that we might buy a machine, a proper machine, and start to do some environmental management. We haven't even started with the strongyles here. This is just looking at Anapocephala. To finish up, I'm going to talk very briefly about the small red worm blood test. It was developed to try and give people an indication of the number of worms in horses that wouldn't be detectable by a fecal egg count. If there's a take-home message today, particularly for the vets here, it's really to be used as an aid to direct treatments in low infection risk settings. So please don't send me blood samples from stud farms where they're likely to be in a high infection risk setting, because the horses will have a high antibody level because they'll have a higher burden of infection, and most of them will be positive anyway. The best value is to use it in low infection risk setting What's a low infection risk setting? A racehorse standing in a stable that doesn't eat very much grass, and a racehorse that probably gets ivermectin every 4 to 8 weeks. Think about using the blood test in those circumstances to reduce anthelmintic use that's totally unnecessary, and to take a more evidence-based approach to treatment. It can be used to support a diagnosis of larval cyatostominosis. These horses, again, will have a lot of off-scale samples that come back, and you can use it at herd level as an epidemiological tool to say, actually, these horses have got very, very high levels of strongyl infections. You need to do something about it. You need to do dung removal. You need to check efficacy. You need to do lower stocking density. You need to do mixed grazing. So it can be used as a tool. And because it's a very sensitive test and it detects low levels of infection, I'll tell you about a low level of infection, it's very good in colitis cases that you don't know what the etiology is to rule out cyatostomins or small strongyls from colitis. And we've got a study ongoing with Bell Equine and other practices just now, like Rossdale's as well, to look at the use of the test in cases of colitis. So it measures antibodies is a bit, I would say, more technically challenging to develop the test. As one of the inventors, I can say that, because we don't actually use antigens or proteins from the worms themselves, because we'd have to digest them out of horse guts, and that's ethically and financially unviable. So what we did is we actually identified the genes of proteins that were of diagnostic value in small red worm. We cloned and expressed them, and it's a recombinant, a bacterially expressed 3 proteins that we measure the antibody response to in the test, and it reports results as serum scores, because again we measure it against a calibration curve. We report serum scores, which provides information on worm burdens of 1,000, 5,000 and 10,000 small red worms. So these are low worm burdens from what you know from what I said earlier. And based on a serum score result that we would provide back to your vet and a risk assessment done by your vet, he or she can provide advice to apply a treatment at either of these 3 scores. And because it's a blood test, again, we don't recommend that it's used until a minimum of 4 months after the previous worming treatment. We've provided very detailed guidelines for people to use, which are accessible through our website, about how to use the test with your vet for informing anthelmintic treatments. Again, we strongly advise that it's only used in horses in low infection risk circumstances which are likely to have a low worm burden and therefore are likely to fall negative in the test, but not to be used in high infection risk circumstances, particularly for the use of larvicidal treatments. We'd advise in high infection risk circumstances, youngsters where dung's not removed, that people would still apply a larvicidal treatment of anthelmintic in the late autumn, early winter, probably moxidectin because it's more likely to be effective, but you could use 5-day fenbendazole if you know that the efficacy of that product works by doing a fecal egg count reduction test in the summer. And here it is in practice. So this is Corin's horses. We've been testing them twice annually for 5 or 6 years now, and they haven't had any anthelmintics in that whole time because she religiously poo picks twice a day. She doesn't employ anyone to do it at night, but she goes out in the morning, and when she's finished in the company, she goes out again. She's just got a couple of horses, and these are the sort of results I love to see coming through the system. It's a vet that's gone out to a yard. They've got 1 or 2 horses. They've got immaculate pastures. You could eat off them yourself, and they do a blood test because the person thinks, oh, I might do a larvicidal treatment, and the vet might say, you might not need to do it because it's so clean. Take a blood sample, and you'll see that the horses are under 1,000. I'm amazed how many horses fall under 1,000 small red worm. These are really clean pastures. And we work with a big clinic in Belgium, sends us a lot of sport horse samples. And again, these are show jumpers, dressage horses primarily. And what we find is that 62% of those horses, 62% fall under 1,000 total cyathostomin burden. So don't listen to other parasitologists say, oh, horses have got tens of thousands of cyathostomin. If they're not eating grass or they're eating very clean paddocks, they're likely to have lower burdens of worms, and now that can be measured. And 19% fell within the 1 to 10,000, and only 19% of those horses were above the 10,000 burden threshold. This is an interesting one. This is theoretically a low-risk racing yard in Yorkshire where we tested 56 horses that had received regular interval treatments all the time in the winter this year. And so you would expect that probably these horses won't have many antibodies to cyathistomins because actually they're race horses. But it turns out the trainer turns them out to a little paddock with no dung removal. And it's exactly as Paul said, think about everywhere when you're doing management. So what we found was when we tested the 56 horses that actually 32% of them still had very low burdens between 1,000 and 48% of them had burdens below 10,000 worms, but 52% fell above this threshold. So it's a really useful test because the vet could then go back to the client and say, well, we need to do something about your dung removal, but you also don't need to keep giving these horses interval treatments, which was what he was doing. So this is the sort of situation that we'd like people to consider, particularly in the sport horse and racehorse sector, if trainers or people that own sport horses continue to give interval treatments, because that's what's always been done. So finally, just bringing it all together, because I'm sure everybody is ready for their lunch, is how do we integrate all that? Because we pushed a lot this morning at parasite control to you. And basically this is just like, because people always used to say, can you give me an annual planner? And this is the sort of thing that you could do. Always risk assess, that's the first thing. And secondly, if you've got horses that graze out over the winter, consider a fecal egg count in the late winter. We found that in our thoroughbred study. There was all these yearlings and 2-year-olds that were turned out in the winter together, and we egg counted them in the sort of January, February, and their egg counts were really high. It was an odd ratio risk factor for high egg counts with these animals, because they probably had moxidectin back here, and then their egg counts were going up. Tapeworm test in the spring, as I recommended, to identify shedders, fecal egg count to identify shedders, treat those, and hopefully you'll only be treating maybe about 1 in 5, particularly in adult populations. It'll be a higher percentage in younger horses. Fecal egg count in the summer, test your efficacy in the summer. Depending on what product you use, you might want a fecal egg count again in sort of late summer, early autumn, and then come back in the autumn with a tapeworm test to identify any horses with higher burdens that may be clinically relevant. And in low-risk circumstances, where horses are likely to have lower burdens, you can use the test to prevent people and try and discourage them from using an annual larvicidal treatment in all horses, and you can apply the test then. But always, 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 you have to match this with excellent pasture management and low stocking densities. Youngsters, again, the only thing I'm going to say here is you might have to increase your frequency of testing. You're probably going to have to give a larvicidal treatment in the autumn for small redworm because they're high risk. And in some cases, depending on how they're managed, they might even need a second treatment in the winter. You could do that based on egg counts. Tapeworm twice a year because they're high risk, unless the test indicates low prevalence, and you can go down to once a year. Foals, because we can't detect parascaris, we recommend that you treat foals 2 months. At the moment, we're recommending fenbendazole, but you would probably want to test the efficacy of that later on. And then from 4 months old, you can fecal egg count, assess the foals every 2 months to work out whether you need to treat for parascaris, or whether you need to treat for strongyles, or whether you need to treat for ascarids and strongyles. And you would select your wormer based on the egg species identified. Small redworm larval stages are undetectable, but we wouldn't recommend the small redworm test for foals. We would recommend that a larvicidal treatment in foals old enough be applied in the late autumn, early winter. And again, like the yearlings, you might need a second treatment later on, but again, work with your vet and do a risk assessment around that and do some fecal egg counts, and they can be tested for tapeworms from 6 months. We pick up antibody in saliva of foals if they're suckling, so we wouldn't recommend the saliva test for foals that have still got milk in their mouths, because the antibody in the mare's milk gets detected in the test. There is the worry about Strongylis vulgaris that I mentioned earlier on, and I suggested that you could speak to your vet and they will get in touch with a parasitology lab who could perhaps do larval culture to identify large strongyles if you have not been using macrocyclic lactones for many years. Because some of the studies, particularly in Denmark, where they've got very strict diagnostic-led treatment protocols, have observed a re-emergence and an increase in prevalence of this parasite, where people have been applying fecal egg count directed treatments for many years. Again, quarantine, just to complete the whole picture, is always based on risk assessment. If you've got a verifiable worm control history, and if you trust it, then you would place into a lower high risk category based on what you know. Horses that you don't have a history for, immediately place into a high-risk assignment, and you can either do a test and treat or a treat-only approach, working with your vet, depending on the risk assignment and the type of stock that you are bringing in, and the type of stock and type of paddocks that you're putting that horse onto. Keep in mind that it's not all about worms, as Paul said. Obviously, your horses can introduce all other sorts of nasty pathogens, and 2 to 3 weeks quarantine is recommended, if possible. And the takeaway message today for you guys is, remember, with poor pasture management, you get higher levels of infection on pasture, which means contamination is higher. More horses will be likely to be infected and have higher worm burdens. Therefore, a higher proportion will test positive in any test that you use. You'll apply more wormers and increase selection pressure for drug resistance. On the flip side, if you take the time to improve your pasture management, your contamination will be lower. Less horses will be likely to be infected and have lower burdens. Therefore, a lower proportion will test positive and less wormer treatments will be applied, and reducing selection pressure for resistance. And coming back to what I said at first, we're at the situation now where it's probably, we can't go back, there's no evidence that there's any reversion to susceptibility in drug-resistant worms, but what we can do is protect the products that we've got left that still work either reasonably well or to some degree. I'd just like to finish up to thank particularly the organisers so much for having me here today and giving me the opportunity to speak to you all, and for your patience and listening to me until this time. And if you want any information, please feel free to reach out. Thank you.
Thank you so much, Jacqui. I think, like you've highlighted, it's so important. You've given us the confidence in those low-risk areas that they might not need that larvicidal autumn treatment. And with our moxidecting, you know, we're seeing resistance now. And so if we can really reduce, because historically, again, it's one of those things that everyone was doing in autumn because that's what we were told to do.
For years.
I know. And now we need to stop doing that so that we can save it for our stud farms that really need it. Thank you.